Hello friends, today we are going to start with a new chapter that is generics in Java. Since the original 1.0, many new features have been added or introduced to Java. One that is generics, and it has the most profound impact on the programming language. Introduced by Java 5, generics changed Java in two important ways. First, it added a new syntactical element to the language. So, generic is a new syntactical element in a language. Then, second is caused changes to many of the classes and methods in the core API. So many of the classes that are already introduced in Java and methods in the core API was changed due to use of generics. Because generics represented such a large change to the language, some programmers were reluctant to adopt its usage. Okay, so there are so many important features because of generics introduction. So for that purpose, it is some programmers were reluctant to adopt its usage. However, with the release of Java 6, generics can no longer be ignored. Simply put, if you will be programming in Java Software Edition 6, you will be using generics. Fortunately, generics are not difficult to use and they provide significant benefits for the Java programmer. Okay, so for Java, from Java 5 to Java 6, there were options for the programmer to eliminate the usage of generics, but from Java 6, you cannot longer, you can no longer uh, try to avoid its usage or advantages. Through the use of generics, it is possible to create classes, interfaces, and methods that will work in a type-safe manner with various kinds of data. Many algorithms are logically the same, no matter what type of data they are being applied to. Okay, so it is very easy to use generics, and it will be used to work in a type safe manner with various kinds of data that we are operating upon. For example, the mechanism that supports a stack is the same whether the stack is storing items of type integer items, string items, object items, or thread items. So data can be anything. Data can be int, data can be string, data can be object, data can be thread, but the basic implementation or main implementation of stack will remain the same. So that means no matter what type of data they are being applied to, those algorithms will be same. You can define algorithm once, independently of any specific type of data that we have seen just now, and then apply that algorithm to wide variety of data types without any additional effort. Okay, so write once, use forever. The expressive power generics added to the language fundamentally changes the way that Java code is written. Perhaps the one feature of Java that has been most significantly affected by generics is the collection framework. Okay, so collection framework we will be seeing in a separate chapter, that is upcoming chapter after these sessions. So one of the main features that Java will be affected by the use of collection framework. The collection framework is a part of Java API and is described in detail in chapter 16 or 17, but a brief mention is useful now. So just we will introduce it here and we will introduce it in detail in chapter 17. A collection is a group of objects. Collection is a group of similar types of objects. It is like an array. In array, same type of data type is grouped together to hold an array. Likewise, a collection is a group of similar type of objects. The collection framework defines several classes such as lists and maps that manage the collection of objects. The collection classes have always been able to work with any type of object they are operating upon. The benefit that generics add is that collection classes can now be used with the complete type safety. So you can work with any type of data type irrespective of with a no regard of which type of data you are using. The basic implementation will be the same. Addition to providing powerful new language element, generics also enable distinct features to be substantially improved. Collection framework is substantially improved by use of generics. This is why generics represents such an important addition, and we will see the syntax theory and use of generics. It also shows how generics provide type safety for some previously difficult cases. Once you have completed this chapter, you will want to examine chapter 17, which covers the collection frameworks in detail. Okay, so when we will see in detail, we will see all types of collection in that, what is the theory, what is the syntax of those collections, and how they are implemented in Java applications. There you will find many more examples of generics at work. Generics were added by Java 5. Source code using generics cannot be compiled by earlier versions of Java compilers. So whatever is the compiler before Java 5 cannot compile the source code generated by generics. What are generics? At its core, the term generics means parameterized types. Parameterized types are important because they enable you to create classes, interfaces, and methods in which the type of data upon which they operate is specified as a parameter. Okay, so in short, they enable you to create classes, interfaces, and methods in which type of data upon which they operate specified as a parameter. Okay, so you will create classes, you will specify suppose type of data on which your operate will be passed as a parameter. So generics are the parameterized type. Using generics, it is possible to create a single class, for example, that automatically works with different type of data. A class, interface, or method that operates upon a parameterized type is called a generic, as in generic class or is generic method. It is important to understand that Java has always given you the ability to create generalized classes, interfaces, and methods by operating through the references of type object. Because object is a superclass of all type of other classes, object reference can refer to any type of object. So before the Java 5, Java introduced the generics, but before Java 5, the basic object class and basic object class reference was used to refer any type of object. Okay, so if you are creating a reference of class object, that reference can refer to any type of object, any type of class, any type of interface, and so on. Thus, in pre-generics code, that is pre-generics, that is Java 5, before Java 5, generalized classes, interfaces, and methods use object references to operate upon various types of objects. In short, various types of data. The problem was that they could not do so with type safety. Generics added the type safety. They also streamlined the process because it is no longer necessary to explicitly employ cast to translate between object and the type of data that is actually being operated upon. When we were using with operating upon object, we were had to cast to that particular object to particular type of object we are referring to. Okay, if this class is being this object is being referred to by say particular class, that will be cast to that particular class type or any other type that you are operating upon. Suppose object is a generalized object and you want the integer representation of object, you will cast it to integer. If you want the float representation of object, that object class object, you will convert or cast to the float representation of object, and then you will operate upon. But generics, in generics, it is no longer necessary to explicitly employ casting to translate between object and the type of data that is actually being operated upon. All casts are automatic and implicit. You don't have to worry about it. Thus, generics expand your ability to reuse code and let you do so safely and easily. A warning to C++ programmer who have already learned with C++, although generics are similar to templates in a C++, because template is a generalized structure, in which we were replacing that template T with any type that we wanted. They are not the same. So template and generics are not the same. There are some fundamental differences between the two approaches to generic types. If you have background in C++, it is important not to jump to conclusion about how to generic works in Java. First, you have to understand its theory, and first you have to practice, and you don't need to create a conclusion about that generic and templates are same. A simple generics example. Let us begin with a simple example of generic class. The first is the generic class gen, and the second is generation demo, which uses gen. The simple generic class here T is the type of parameter that will be replaced by the real type when an object of type gen is created. Okay, it is same as the template, but it is not actually is equal to the template in C++. We will see class generics T object, declare that object of type T, any type. You can write it over there like integer, float, boolean, and string or char or anything. Pass the constructor reference to an object of type T. Generics T object is equal to O. This is the initialization process. This is the return process. Get object, T get object, return object. Then show type of T, void show type, system.out.println. Type of T is object.get class.get name. Okay, so here what we are doing, we are getting the name and displaying it in system.out.println. Now, main method. In main method, we are creating generic object of type integer. Okay, so everything will be whenever we have written a T, the T will be replaced by the integer class. Create a generic integer object and assign its reference to I object. Notice the use of autoboxing to encapsulate the value 88 with the integer object. Like we have seen autoboxing, that is auto-casted to simple int primitive type to integer wrapper class. That is called as autoboxing, and it is done automatically. Now new generic integer, it is created. Show the type of data used by iObject dot show type. This will display the type of T is object.get class.get name. It will display the integer. Okay, get the value in iObject. Notice that no cast is needed. Now integer V is equal to iObject.get object. So now get object, what it is doing, it is displaying the object. So now it will automatically convert from the wrapper class integer to primitive variable V, and this will be displayed over here. That is 88 is already wrapped to an integer class integer capital I, and now it is automatically converted to primitive type V, integer V, and it is displayed over here. Create generic object for strings. Now done with the integer. Now we will create the generic object for string. Generic string object is equal to new generic string, generic text. Now show the type of data, show type, it will display the string. Get the value of string object. Again notice that no cast is needed. This object will be automatically converted to string, primitive type string, and its value will be displayed. Type of T is java.lang.integer, value is 88. Type of T is java.lang.string, value is generic text. So now we will see the program in detail. Notice how generics is declared by the following line: class generics T. T is the name of type parameter. The name is used as a placeholder for the actual type that will be passed to generics where an object is created. Okay, so T is a name of type parameter, is used as a placeholder for the actual type that will be passed to generics. So T will be replaced by the actual type when an object is actually created. So T is used within generics whether the type parameter is needed. T is contained within opening and closing, greater than and less than special characters. This syntax can be generalized. Whenever type parameter is being declared, it is specified within the angle brackets. These are the angle brackets, less than and greater than. Because generics uses a type parameter, Generic is a generic class which is also called a parameterized type. Now, T is used to declare an object called OB as shown here. TOB, declare an object of type T. As explained, T is a placeholder for the actual type that will be specified when a generic object is created. Okay, so here also, whenever you are creating an object, so T will be replaced by the actual type when the generic object is created. OB will be an object of type T passed to T. For example, if type string is passed to T, then in that instance OB will be of type string. If integer is passed to T, then in that instance OB will be of type integer. If float is being passed to T, then in that instance OB will be of type float. Now consider the constructor. Generics or TO object is equal to O. This is the parameterized constructor and this is the initialization process. Here also this T will be replaced by the actual type. Actual type is O is written by the type of type passed to T when the gen object is created. Also because both parameter O and the member variable OB are of type T, they will be both of the same actual type when a generic object is created. Okay. So OB's type and O type will be the same when actual gen object is created. The type parameter T can also be used to specify the return type of a method when you are getting the object. T get object, return object, as is the case with the get object method shown here. Because OB is also type T, its type is compatible with the return type specified by the get object. The showType method displays the type of T by calling getName on the class object returned by the call to getClass on object. ShowType will display the which type of generics type is replaced with on the class object returned by the call to the getClass on object. That is our display output java.lang.integer, java.lang.string, etc. etc. The getClass method is defined by the object class and is thus a member of all class type. So if you want to find out the class of the particular object, you will use the method getClass. It returns a class object that corresponds to the type of class of the object on which it is called. Class defines the getName method which returns a string representation of the class name. Okay, so there is a getName method in a class which returns a string representation which type you are using. You are using integer, you are using string, you are using float, you are using boolean, etc. etc. The generics demo class demonstrates the generic gen class. It first creates a version of gen for integers like in gen integer I object. So I object is a type is of type integer. Then look closely. First notice that the type integer is specified within angle brackets after gen. It is compulsory. Integer is a type argument that is passed to gen's type parameter t, and it creates a version of gen in which all references to t are translated into references to integer. So in short, t is nothing but integer in this case. Thus for this declaration, OB is of type integer and the return type of get object is of type integer. Before moving on, it is necessary to state that Java compiler does not actually create different versions of gen or of any other generic class. Okay, different versions of not created because for each type of for each and every generic class you are replacing the actual object over there. If you are passing integer in angle bracket, the integer object will be created. If you are passing the float object in bracket, the float will be created. If you are passing the string will be created, and so on. Although it is helpful to think in these terms, it is not what actually happens. Instead, the compiler removes all generic type information, substituting the necessary cast to make your code behave as if specific version of gen were created. Whenever you are creating object, the T will be simply replaced by the type of object you are creating at the time of public static void main. Okay, if you are passing integer, integer will be created, and in the throughout code it will behave as all the generic type information is about integer only. Thus there is really only one version of generics that actually exists in your program. Okay, depending upon which type of object we are creating. The process of removing generic type information is called erasure, and we will return to this topic later. The next line assigns to I object reference to an instance of an integer version of a gen class. So how to instantiate I object is equal to new gen integer 88. So it will assign I object a reference to instance of an integer version of the gen class. So in short, what it is doing? It is creating object of type integer. When the gen constructor is called, the type argument integer is also specified. This is necessary because the type of the object, in this case I object, to which the reference is being assigned, is of type gen integer. So what you have to remember overall is, whenever you are creating object of particular type, all the specific capital T, are replaced by that particular object. Thus the reference written by new must be also type gen integer. If it is not, compile time error will result. Okay, if whatever you are returning, whatever you are assigning, whatever you are initializing in constructor, all types should be same, of type integer only in this case. For example, I object is equal to new gen 88.0 will result in error, compile time error, because you are creating generic object of type integer only. So you have to differentiate using integer wrapper class only. Because I object is of type generic integer, it can be used to refer to an object of generic double. This type checking is one of the main benefits of generics because it ensures type safety. So you don't have to worry about it. You just have to replace the T with that particular type. As the comments in the program state, this assignment makes use of auto boxing to encapsulate the value 88 to the primitive type integer. Sorry, from the primitive type integer to the wrapper class integer. This works because generic integer creates an constructor that takes the integer argument. Because an integer is expected, Java will automatically box 88 to the wrapper class integer. The assignment could also have been written explicitly like new integer 88, but since auto boxing is available, we are not writing in such a way. Okay, the program then displays the type of object within I object, which is integer. Then the program obtains the value of OB by use of following line: integer v is equal to I object dot get object. Here the get object will be of type wrapper class integer, and it will be automatically auto unboxed to the primitive type integer. Because the return type is T, which was replaced by integer when I object was declared, return type get object is also integer, which unboxes to integer when assigned to V. Then it is no need to cast the return type of get object to integer. It is not necessary to use the auto unboxing feature. The preceding line could have been written like this too: I object dot get object dot integer value. Both lines are having the same meaning. The auto unboxing feature is will make the code more compact, and you don't have to write each and everything by your own. Everything will be done automatically. Then GenDemo creates an object of type GenString. Here also it is created automatically. Argument string, it is replaced by generic test, and the type T is replaced by string. This creates conceptually a string version of Gen, as the remaining lines of programs demonstrate. Generics work only with object. When declaring an instance of generic type, the type argument passed to the type parameter must be a class type. Okay, so it will work only with object. It will not work with the primitive type. So whatever you are creating or passing to will be only the wrapper classes, not the primitive type. Like you cannot write it like int int. You have to write only the wrapper class of integer, that is int ger. Okay, you cannot use a primitive type such as int or char For example, with generics, it is possible to pass any class type to T, but you cannot pass the primitive type. You cannot write it like gen in string object is equal to new gen in 53. It will give you error. You have to write here like intgr wrapper class name. Not being able to specify primitive type is not a serious restriction because still you can use the wrapper classes. Okay, you can still use the type wrappers as the preceding example to encapsulate a primitive type. It will be automatically boxed and it will be automatically unboxed. Further, Java's auto-boxing and auto-unboxing mechanism makes the use of Java type wrapper transparent. You don't have to code anything extra. Generic types differ based on their type argument. Okay, so when you are creating different generic objects, so how you will differentiate between that object depending upon the type argument they are being passed to. A key point to understand about generic type is that reference of one specific version of generic type is not type compatible with the another version of same generic type. Okay, reference of one specific version of a generic type. Reference means one specific object of that particular generic type is not type compatible with another version of the same generic type. For example, assuming that the program I object is equal to string object, you cannot write like this because integer is a different thing and string is a different thing. Even though both I object and string object are of type generic T, you are replacing only integer and string, creating two different types of generics. Still you cannot create a reference to refer to each other. They are references to differ to different types because their type parameters are different. This is the part of way generics add type safety and prevent errors. Okay, how generics improve type safety? Whenever you are creating object, that T will be automatically replaced with the wrapper class that you are using or you are trying to use in your program. You might be asking yourself at the following question, given that the same functionality found in the generic gen class can be achieved without generics by simply specifying object as a data type and employing the proper class. What the benefit of making generic? When you are using object, you have to typecast by your own, and here with the use of generic, the typecasting automatically takes place. For that purpose, generics improve type safety. The answer is that generics automatically ensure type safety of all operations involving gen. In the process, they eliminate the need for you enter casting from one data type to another data type and to type check code by hand. Okay, so every time type checking will be done automatically. To understand the benefits of generics, you must consider the following program that creates a non-generic equivalent of generic. Non-generic object OB. Here, the main class object will be created. Pass a constructor of type reference to an object of type object or non-generic object O. OB is equal to O. Get object, return object. Show type of object is ob.getClass.getName. Okay, so non-generic object is created. Create non-generic object. I object is equal to new non-generic 88. Auto boxing still occurs. I object of shape show type will show the integer type. Then here I object dot get object will be casted to integer wrapper class and then it will be stored to the V and value will be displayed. Then another non-generic object will be created. Then its type is shown. Again notice that a cast is necessary. String object dot get object will be converted to string and it will be saved to str and it will be displayed. Okay, I object and is equal to string object. Okay, it will give you this will be compiled but it is conceptually wrong. And second one, I object dot get object will be converted to integer and then it will be stored to V. It will give you runtime error because this object will be storing the string representation generic text and this will be tried to convert to integer wrapper class and it will be stored to V and it will give you runtime error. There are several things of interest in this version. Notice that non-gen replaces all uses of T with object. This makes non-generics able to store any type of object as in the generic version, but it also prevents Java compiler from having any real knowledge about the type of data actually stored in non-generic, which is bad for two reasons. Okay, when you are using objects, Java compiler does not actually know which type of object you are creating actually, and which is bad for two reasons. Explicit cast must be employed to retrieve the stored data every time, and second, many kinds of type mismatch errors cannot be found until runtime. Okay, so this will create compile time errors as well as runtime errors. So it is complicated for you to program. So now we will see the each and every problem. Integer v is equal to integer I object dot get object. Because the return type of a get object is object, the cast to integer is necessary or compulsory to enable that the value to be auto unboxed and stored into v. Okay, cast to integer is necessary to enable that the value to be auto unboxed and stored into v. If you remove the cast, the program will not compile. With the generic version, this cast was implicit, and for the non-generic version, cast must be explicit. You have to explicitly cast it. This is not only inconvenience but also a potential source of error. Okay, so it can generate the error if you are not casting appropriately. Now consider the following sequence from the near end of the program. I object is equals to string object. So I object now refers to the string representation, and then you are trying to convert that string to integer wrapper class, and again you are trying to store it into v, which is of type integer. So it will give you the runtime exception. String object is assigned to I object. String object refers to object that contains of type string, not an integer. It is syntactically valid because all non-generic references are the same of the main class, that is object, and any non-generic references can refer to only other non-generic object. However, the statement is semantically wrong, as the next line, the return type of get object is cast to integer and then an attempt is made to assign this value to v, which is of type integer. Okay. This trouble is that I object is now referring to an object that stores a string, not an integer. Without the use of generics, the Java compiler has no way to know this because everything is stored into base class object. But when you are storing this type in generics, it will be automatically understood because the T will be replaced by the particular type when the generic object is created. Instead, a runtime exception occurs when the cast to integer is attempted. As you know, the extremely bad to have runtime type exception occur in your code. It is very much irritating. The preceding sequence cannot occur when generics are used. If this sequence were attempted in the generic version of the program, the compiler would catch it and report an error, thus preventing a serious bug or runtime type exception that will result. The ability to create a type-safe code in which type mismatch errors are caught at compile time is a key advantage of generics. So anything that you will write in a generics code, every error will be found out. Although these object references to create generic code has always been possible, that code was not type safe and its misuse could result in a runtime type exception. Okay, so this way we have found out we have completed all the theory part in chapter theory part 1 of generic. In the upcoming sessions, we will try to cover the remaining topics of chapter generic. So meet you in the next sessions. Thank you so much.